Alright, class, today we're going to have a real short video. We're going to be looking at some equations of lines. So again, this is all stuff that you saw in Algebra 1. So last couple days, we looked at slopes. Now we're going to put those into actual equations. And I'm just going to do a couple examples of each from your homework, or maybe one example from each section. So to get the actual notes part out of the way here, our slope-intercept form is something that I hope you've seen before in the form y equals mx plus b. So this is a pretty standard way to put an equation of a line, especially if you want to graph it. So we'll see why that works really well for graphing in just a minute. So our m is equal to the slope that we've spent the last couple days finding. And our b is the y-intercept, not the x-intercept. It has to be the y-intercept. So remember that our y-axis is the one that's up and down here, the vertical. So y-intercept means where does this line touch the y-axis? So let's just do a couple of example problems here. So on number 1 here, given the graph, write the equation of the line in slope-intercept form. So we need two things. We need a slope and we need the intercept. So the first thing I'm going to do is actually get a couple of these points in. So on this bottom one, we're not moving left or right. So our x-coordinate is 0. And actually, why don't I move this over here so we can see it a little bit more easily? Our x-coordinate is 0 and our y-coordinate is down 1, 2, 3. So -3. So we've got one point at the coordinate 0, -3, and we've got another point at the coordinate 2, 1. So over 2, up 1. And we need to find a slope between these two. So our slope is equal to our difference in y's over our difference in x's. So 1 minus a -3, and let me move that up where it's out of the way, over, let's see, and we want to make sure we get the order right here, so 2 minus 0. So this was my second point, the one on the right, so I used that and subtracted the first point. Okay, 1 minus a -3 is the same thing as saying 1 plus 3, which is 4. And then 2 minus 0 is 2. So 4 divided by 2 is also 2. So our slope is going to be 2. So m equals 2. And then our b is what number we touch the y-axis at. And it's actually this point right here. So 0, -3. So our b is -3. And now that's all we need to actually write the equation of this line. So in slope-intercept form, y is equal to m, which is 2, times x, plus b. Well, our b is negative, so I'm going to say -3. And every point on that line will have an x-coordinate and a y-coordinate that makes this equation true. So right there, y equals 2x minus 3. Okay, let's go the other direction. We are given a line, or we're given an equation of a line, and we want to graph it. And this is where slope-intercept really shines. So our intercept here is this -1. So that means that I can put this point right here, -1. That's our 0, -1. That's our b value, essentially. And then we know the slope is 5 over 4. And remember, it's rise over run, so always y over x. But what that means is I'm going to move up 5 and over 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. So I know that this point right here is also on my line. And then I'm just going to insert a line here. And there we go. So we have graphed the line there using the intercept, that -1, and then using the slope to find a second point. And now we've got it, and anywhere that is on this line will fit this equation. Okay, The other type of equation that we're looking at in this section is standard form. So in standard form, we've got the equation ax plus by equals c, where a, b, and c are some constants. They're just some number. And this author wants you to convert them to slope-intercept form, which we'll do. But I want to show you something. So this says because standard form does not give you slope, we need to convert it. Well, it kind of does. So our slope is always going to be m equals negative a over b. So we do actually have the slope in this form if we think about it a little bit. So if we want to get this into slope-intercept form, then we do the same two things every time. We subtract this ax over to the other side, or add if it's negative, and then we divide by b. So when we do that, we always have a negative a over b in front of the x term, and that's our slope. So yes, you can move the equation around, and we will do that. In fact, I'll pick this middle one, this 8, because 7's too easy. But we'll see that that actually works. So let's put this into our slope-intercept form, our y equals mx plus b. And we'll see that our slope, our m, actually is this negative a over b. Okay, like I said, we're going to do the same two moves every time. So I'm going to subtract 5x from both sides. That will give me a new equation of 2y is equal to negative 5x minus 2. And now I'm going to divide both sides by 2 so that we can actually solve for y. So y is equal to negative 5, oops, can't hit the right button, negative 5 over 2 times x, and then we've got this negative 2 divided by 2. Don't forget that you have to divide both parts of that right side, and we get y equals negative 5 halves x minus 1. And that is our equation, whoops, wrong shape. That is our equation in slope-intercept form, and notice our a was 5, and our b was 2, and our slope is negative 5 over 2. So don't let anyone tell you what you can and can't do. We totally can find the slope from standard form. Okay, and then we can graph each line in standard form, and this actually is where it becomes pretty useful to actually put the equation into that slope-intercept form. So we're going to do the same thing. We're going to subtract away the x. I'm looking at number 13 here. Subtract away the x, so we get negative 2y is equal to negative x plus 8. And then we want to solve for y, so we're going to divide both sides of this equation by negative 2. So that's going to get us a y equals 1/2 x, because we've got a negative divided by a negative, so it's a positive. And then 8 divided by negative 2 is a negative 4. So there is our new equation, and it's in slope-intercept form, which makes it very easy to graph. So our intercept is this negative 4, 1, 2, 3, 4. And our slope is our rise over run, so up 1 over 2. Up 1 over 2. Up 1 over 2. We only need one of these points, but I'm just going to go ahead and make it a little bit longer. And then we can also go down 1 and to the left 2. These are all on the same line. So now I'm going to get out my line tool, draw a line between these, and we have successfully graphed our line here. And you can do the next one. Okay, so now the last thing we want to look at in this section here is vertical and horizontal lines, and these are the only ones where we don't use both x and y. So if we have a vertical line, remember that our slope is undefined because it's essentially dividing by 0. So we have an undefined slope, and the y value doesn't matter. So the y value changes up and down but it doesn't change in relation to the x value. The x value is just staying the same. So what we can say here is that this equation is only in terms of x. Every x, or every point where x is equal to -1 is going to be on this line. So that's actually the equation of the line. We just take the x-intercept right here, and we use that as the equation. So x equals -1. And then we've got a similar thing with this horizontal line here. So our horizontal line had a slope of 0, because it's going to be 0 over something. But this time the x doesn't really matter. The x isn't even in the equation. The equation is just going to be every single point where y is equal to 3. Because 3 is our y-intercept here. So any point where y equals 3 and the slope is 0 is going to get us there. All right, so this should hopefully be a lot of review, should be another easy assignment, and make sure you bring questions if you have any, and we'll see you in class.